Hello and welcome to the Unit 2, Section 3 video on deductive reasoning. So in this section we are going to talk about a different type of reasoning than what we've been talking about in the last two sections. And the best way to describe deductive reasoning is by comparing it to inductive reasoning. So you've learned that one counterexample is enough to disprove a conjecture. But to prove that a conjecture is true, you must use deductive reasoning. Deductive reasoning is the process of using logic to draw conclusions based on rules or laws. So remember, when we did inductive reasoning, we were making an assumption to come to our conclusion. And that assumption could be true. It's hard to prove it's true, but it could most certainly easily be proven false by using a counterexample. Well, in deductive reasoning, we are using logic to draw conclusions based on rules or laws, which means there is some specific rule or law in place that makes our conclusion true. And those rules or laws are true. They are taken to be true. They have been shown to be true. So these rules or laws, these are basically your evidence. And that's what's going to help your conclusion hold up in a court of law, so to speak. Okay? So let's do a couple of examples here talking about the difference between the two. So here we're going to determine if each conclusion is a result of inductive or deductive reasoning, and then we're going to give why. Okay? So let's talk about A. The last two times the ice cream truck came to the neighborhood, it was after 3 p.m. I can see the ice cream truck, so it must be after 3 p.m. This is an example of inductive reasoning. And the reason that is inductive is that there is no guarantee that the truck won't arrive earlier in the day. Okay? Because there could be one day where the truck's just running ahead. People at the earlier stops didn't want any ice cream that day. So maybe the truck arrives at 2:30 instead of 3 o'clock. So we can make the assumption, because usually the truck's there after 3 p.m., but it's not a hard and fast conclusion that it's always going to happen. Now, to contrast that, let's look at example B. The ice cream truck's schedule says it runs from noon to 6 p.m. It is 4 p.m. now, therefore the ice cream truck is still running. This is an example of deductive reasoning. And the reason this is deductive is that we know the truck is running somewhere along its route because it is within operating hours. Okay? We know that is operating somewhere because it is within operating hours. And that's because the truck schedule is our law or our rule that we follow to make that conclusion. All right, now let's talk about the law of detachment. In deductive reasoning, if the given facts are true and you apply the correct logic, then the conclusion must be true. The law of detachment is one valid form of deductive reasoning. And it says that if you have a hypothesis and conclusion and that whole conditional is true, so we're taking that whole conditional statement to be true, and P is Q, then we know that Q is true. Okay, so let's look at an example of that. If there is lightning, then it is not safe to swim. Hector sees lightning while swimming at the pool. So what conclusion can we draw from this? Well, the first statement is true. If there is lightning, then it is not safe to swim. We're taking that entire statement to be true. Well, Hector sees lightning while swimming at the pool. We're going to say that's true. So therefore, the conclusion is it is not safe to swim. And in B, if today is my birthday, then I will eat cake. Today I had cake for lunch. Can we conclude that as my birthday? Well, no, because I can have cake any other day of the year for lunch. It does not have to be my birthday. We only know that on my birthday I will eat cake, but we can't necessarily say that I will eat cake only on my birthday. Okay, so there is no conclusion here for this one. All right, so a couple of things to point out. In the first one, the second statement references the hypothesis. Okay, so in the first one, Hector sees lightning while at the swimming pool. This references the hypothesis there is lightning. In B, we couldn't draw a conclusion because what we're referencing here is the conclusion of the first statement. So here, if today is my birthday, then I will eat cake. Today I had cake for lunch. This references the conclusion of our first statement, not the hypothesis. So that's why we cannot reference, why we cannot draw a conclusion. Okay, the law of syllogism. Another valid form of deductive reasoning. It allows you to draw conclusions from two conditional statements when the conclusion of one is the hypothesis of the other. So the law of syllogism, if the hypothesis leads you to the conclusion of something and that conclusion leads you to another conclusion, then the hypothesis from the first leads you to that last conclusion. It makes more sense when you compare it to the transitive property from algebra. Remember, if A equals B and B equals C, then A equals C. This is where I like to say we cut out the middleman. B is the middleman in the transitive property. Q, the conclusion of the first statement, which is also the hypothesis of the second statement, that's the middleman. We're going to cut that out and string those two statements together to form our conclusion. So this is how it works. If possible, we're going to use the law of syllogism to draw a conclusion. If it is not possible to draw a conclusion, we are going to tell why. So in this first one, if it is my birthday, then I will eat cake. If I eat cake, then I will want ice cream. Notice that the conclusion of the first statement is the hypothesis of the second statement. So we can cut out that middleman and conclude, if it is my birthday, then I will want ice cream. So you take the hypothesis from the first statement and put it with the conclusion of the second statement. All right, for B, if Madeline's cat Grady is tired, he will sleep all day. If Grady missed dinner, then he slept all day. Well, the conclusion of the first, he will sleep all day, is not the hypothesis of the second. It's the conclusion of the second. So therefore, we can't string them together, and we have no conclusion. And the reason we have no conclusion is the conclusion of statement 1 is not the hypothesis of statement 2. All right, one last example for this short section. We're going to consider the following true statements. Dad will give me $10 if I ace the next geometry test. I will ace the geometry test if I study really hard. We're going to rewrite the sentences as conditional statements, and then we're going to see what conclusion we can draw from the information. So, the first statement, if I ace the next geometry test, then Dad will give me $10. Now, the reason that the hypothesis is I ace the next geometry test is because the result of that is that Dad will give me $10. So that's our conclusion. For the second statement, I will ace the geometry test if I study really hard. Well, there we've got an if in there, and if I study really hard, the conclusion is then I will ace the geometry test. Well, can we come up with a conclusion for this one? Well, if I ace the next geometry test, then Dad will give me $10. If I study really hard, then I will ace the geometry test. Is the conclusion of the first the hypothesis of the second? Well, not in this order. But if we go around the other way, if I study really hard, then I will ace the geometry test. If I ace the next geometry test, then Dad will give me $10. We can come to the conclusion that if I study really hard, then Dad will give me $10. So this became our first statement, and this became our second statement to come to that conclusion. If I study really hard, then Dad will give me $10. Okay, this concludes section 3 of the Unit 2. We have one more section left to go. In our next section, we are going to talk about proofs. And this is going to be, we're going to be using some of this logic in proofs, but proofs are going to be almost kind of like their own thing as well. And proofs are going to be a very important concept to get down because we are going to be revisiting this as we go throughout the rest of the semester. So proofs are coming up in the next video to wrap up the unit.